This lesson is for Advanced Algebra, Lesson 3-4 on finding an equation of a line. We're going to be using the point-slope formula to find the equation of a line. We're also going to be talking at the end about piecewise linear functions. This formula that we're focusing on today is one that I'm hoping students will learn to appreciate. I think most students are mostly comfortable with the slope-intercept equation, y equals mx plus b, and we've been spending time lately doing a lot of work with the linear combination equation of ax plus by equals c. However, the point slope formula I believe to be versatile enough to use in place of both of those other two, and I'm hoping students learn to memorize it and learn to use it very comfortably. The point slope formula itself has a coordinate or a point in it that I've marked here in green with the subscripts of 1 on both the x and the y, and a slope which we're used to calling the m value. The other two pieces of the equation, the plane x and the plane y, are simply going to be the variables that we're working with. So you have y minus y1 equaling m times x minus x1. Keep in mind that the y values could either be on the left or on the right. They don't always have to be in the same position. So when do you use the point slope formula? Use it when you're given 2 points or 2 coordinates, because that's all you need in order to form a straight line. You can also use it when you're given a coordinate or a point and a slope. You can plug in the slope for m and you can plug in the coordinate for x1 and y1, and then you simply have your equation. If you need to get it into one of the other two forms, you can simply use the distributive property and redistribute using algebra as needed. So let's try it now with an example. So our first example has 2 coordinates. We're going to go ahead and first find the slope. Can't really do the point slope formula without it, so let's find the slope first. And we're not going to get into how to calculate slope. I'm assuming that most students know how to do that. If they need to learn how to do slope, they should either look that up or ask for individual help. So I'm going to do y2 minus y1 over x2 minus x1. The order here does matter. If you have the numbers in the opposite order of what I have, that's fine, but you need to have 16 minus 12 or 12 minus 16, and then the x values need to follow suit. So in this case, the 16 and the 5 need to be above each other, just like the 12 and the 7 are above each other. So when we subtract there, I get 4 over negative 2, so I get a slope of negative 2. So that's going to be my m value. Then I'm going to go ahead and I'm going to choose one of the 2 coordinates and plug that in for x1 and y1. There is no right or wrong here, you simply need to make a choice. I'm going to choose the first one, and I'm going to plug in the y value for y1, the m that I just calculated, and the x value for x1. Keep in mind that if students decided to choose the other equation, it's still okay. Simply, you would end up with y minus 16 instead of the 12. The slope would remain the same, and the x value would be a 5 instead of a 7. So now let's determine if those two equations are indeed the same. If you go ahead and do the distributive property here, we still have y minus 16, but now we get negative 2x plus 10. And if you add the 16 to both sides, that's going to give you a 26 on this side. Now let's see if we get the same thing on the original one that we wrote in blue. If we do the distributive property there, we get negative 2x plus 14. If I add 12 to that to get the y alone, I would get 26. So I do indeed get the same answer, even though originally here before we distribute they do look different. But both equations are the same. So you could have this answer, you could have this answer, or you could have the slope-intercept version of it, and all three would be considered correct. However, think about quitting after we did this first one. We would have been done a long time ago. So it's a really great formula for students to utilize. As soon as you calculate the slope, incorporate one of the coordinates, and you can be finished. The only reason you would need to continue on is if it was asked for in a certain form. If you were asked to give the equation for the line in slope-intercept form, you'd have to continue on and do the distributive property. If they asked you to put it in standard form, you'd get into slope-intercept first, like we did here, and then we would simply add 2x to both sides to get it into linear combination format. And so that would be another option as well. So I'd like students to give this a try now. Go ahead and attempt to do the same problem on your own. Pause the video and the answer will show up shortly. And so the slope should have been negative 2/3, and when you choose your coordinates you could either have the -4 and the -6 or +2, -15. And that's as far as students need to go. Either one of those answers is considered correct. We're going to do a word problem now to illustrate that they're not always going to be that easy. Sometimes you have to do a little bit of interpreting on your own. This question is about blood pressure, so let's read what it says. The average normal systolic blood pressures are 110 for a 20-year-old and 130 for a 60-year-old male. Find an equation that relates blood pressure B as a function of age A. The way that this is worded, they're giving you a hint here on which variable is which. Since B is a function of A, that means A is our independent variable. That tells us that when we're creating a coordinate out of the information, the A should be our age, the age should be the X, and the blood pressure should be the B, or the Y value. So that's telling us to put the 110 and the 20 into a coordinate in this fashion. So they're telling us that the age is the independent and the blood pressure is the dependent. So then we're going to grab the other piece of information using age first and the blood pressure second. So now students can again go ahead and create an equation out of these two coordinates, and the answer will appear shortly. So we calculated the slope and it reduced down to 1/2 or 0.5. And then when you plug in the first coordinate or the second coordinate, those are the equations that you get. And again, either one of those is perfectly fine. If they ask you to put the equation in a certain format, you may need to go ahead and do the distributive property to continue, but if it doesn't specify, you are allowed to leave it in either of those formats. Keep in mind that you only need one of these, you don't have to have both. If students are curious at all about information about blood pressure, there's a quick little tutorial here on the different numbers related to blood pressure. If you need further information, check out heart.org. The last topic for today is on piecewise functions, and I believe this graph was taken out of the textbook, page 171. At the right is Frank's bicycle trip to Chuck's house. Because this graph does not have a constant rate of change over its domain, it cannot be represented by a single linear equation. But it is possible to write several equations for each segment. The domain here is missing, so let's go ahead and fill that in. Remember that the domain here is your independent variable, and in this case it's t for time, and it looks like the time goes from 0 to 210. So the domain here that we would say or specify is that it goes from t such that t is in between 0 and 210. So because there is no constant rate of change over that domain, we're going to write for each piece or each segment what the different domains and equations are going to be. So let's take the first segment. The first segment starts at 0, 0 and goes to, well, it looks like between 30 and 60. So halfway between 30 and 60 would be 45. And then vertically we're halfway between 4 and 8, so that would be 6. So our first coordinate, our first segment is in between 0, 0 and 45, 6. So let's go ahead and find an equation for the line between those 2 points. So first we would find the slope, which reduces to 2/15. 3 goes into both of those. And then if I use my 0, 0 as my coordinate, I'm going to get y minus 0 equals my slope, and then x minus 0. So when I finish out the zeros here, my equation is simply going to be y equals 2/15 x. Now keep in mind that that only goes between the domain up to 45. So I'm going to write my answer here off to the side. I'm going to put a very large bracket, and I'm going to say that over this domain from 0 to 210, I'm going to do the first part of it. So I'm going to say that y is equal to 2/15 x for just the values between 0 and 45. Then I'm going to take the next piece, the next segment of the graph, and that is basically looking like a horizontal line. And so that horizontal line is right at 6. So the equation for that I know is just going to be y equals 6. But it's only y equals 6 in between the t values of 45 and 60. So now my domain goes from 45 to 60. The next piece is another diagonal portion. So I'm going to take the two coordinates there and find the slope between those and use my point slope formula to find that. So I'm not going to go ahead and finish this question. I'm hoping that students get the hang of it now. There should be an equation for the portion between 60 and 90, and they're going to be able to find an equation for that. Then there's going to be another horizontal line between 90 and 120. So that one looks like it's at 12. So the domain there is from 90 to 120, and so on. So there should be two more pieces to this puzzle, as well as a third piece here that we didn't finish. So I'm hoping that students get the idea there on what a piecewise function is. Once we have all the pieces assembled together, that whole thing will represent the function itself.